Hey, algebra. Do you hear the round of applause in the background? That's just for you. All right. So, this is kind of a weird way to do this video. My document camera has decided it doesn't really want to work, which is cool. So, I actually have some books stacked up in a game and then my phone taped to the top of it so I can suspend it over my notes. Okay. So, like I said, I hope this finds you all well and you are ready for our new adventure into online learning. So this week we're actually doing things that we did before we left. So hopefully this is just a bit of a review for you and shouldn't take too long. So this week we're covering like aspects of linear functions, or oh my gosh, no we're not, that's a lie, aspects of quadratic functions. So, you know, how to graph them, what they look like, where the zeros are, finding the axis of symmetry, find the y-intercept, etc. So today we're just looking at what a quadratic function is. And again, this is review. If it looks familiar to you, it should. All right, so first of all, if we're comparing linear and quadratic functions, for us to draw a linear function, well, there we go. It looks like a line, right? And then a quadratic function, if we will remember, is a parabola. It's a U shape, if you want to call it that, or think of it that way. Remember when we graphed them, we made like happy parabolas and sad parabolas. So we'll do that, just not today. From a table, remember what we're looking for a quadratic function. Well, let's go linear first just so you can see the comparison. So remember, you always have to look at your x's first to make sure they're all going up by the same amount. They're all going up by +1, so that's cool. So then I look at my y's and I see, okay, well, how do I get from one y to the next? So how do I get from -5 to -3? Well, I add 2. And then -3 to -1. Add 2 again. And then 2, and then 2, and then 2, and then 2. And remember, this was called the common difference or the common first difference. And it's called the first difference because the first time we found that difference in the y values, there was a constant or a common number, which was 2. So if we look over at quadratic, again, make sure your x's are going up by the same amount every time. They're going up by 1. Now, if I take a look at how I get from 9 to 4, I subtract 5. 4 to 1, I subtract 3. So for sure, I know right away it's not linear, right? Because if it was, it would have a common difference. So then I'm going to keep going here. So I go 1 to 0, and that is -1. And then 0 to 1 is +1. And then 1 to 4 is +3. And then 4 to 9 is +5. So I kind of do see a little bit of, you know, symmetry here. I see symmetry here as well. And those are both features of quadratic functions. Sometimes. Problem is they're also, like, symmetry is also features of an absolute value function, which looks like just a V. And so you can't always assume that because, like, these are symmetric around a point, this 0, that it's quadratic. But it's a good thing to look for. All right, so anyway, is there a common difference? No. But remember, if we do it again, there might be. So if I go from -5 to -3, I add 2. -3 to 1, I add 2. -1 to 1, I add 2. 1 to 3, I add 2. 3 to 5, I add 2. Now, the fact that this is 2 and these are 2 is a total and utter coincidence, so don't worry about that. But, so the first difference was not common. But the second time I did it, so the second difference is common because they're all +2. And that is a hallmark feature of a quadratic function. If there is a second common difference, then it's quadratic. Okay, so like from a graph, it has to be a parabola. From a table, you have to have a second common difference. And then from an equation, we know that we're looking for a degree of 2. And degree, remember, does not just mean there's an exponent of 2. It means that that's the highest exponent. So if you have like y equals 3x cubed plus 2x squared, that is not a quadratic function. It's actually a cubic function. But if you have a squared term and it's the highest term in there, then it is quadratic. So if you look at 2x plus 3y equals 6, that's not quadratic. That's a linear function. There is no squared term. And here you have y equals 4 times x minus 1 squared minus 8. I have a degree of 2. X is being raised to that. So yes, that's quadratic. Y equals negative 3 plus 7x squared. Yes, that is quadratic. Going down here, y plus 2 equals negative 7x. I don't see a squared term, so no, that's a linear function. Y equals 3x plus 2. Nope. And then y equals 4x squared minus 3x plus 11. I do have x being raised to the second power as the highest degree. So yes, that's quadratic. All right. Okay, so now we have to look at solutions to quadratic functions and what those mean. So remember, there are 3 possibilities of like the number of solutions in a quadratic function. You could have no solution, and I should say no real solutions, because remember, we do have imaginary solutions. And I remember telling you guys all that, and you're like, what the heck? Why do we have imaginary things in math? It's supposed to be real. Well, just because. So no real solutions, 1 solution, 1 real solution, or 2 real solutions. Sorry, I'll put real in there. Now, solutions, you're like, what the heck is a solution? I don't remember. They're also called roots. They're also called zeros. They're also called, and this is how you find them, they're the x-intercepts. So it is, a solution is a point where your parabola crosses the x-axis or hits the x-axis. So in some instances, like I said, it could be no times that happens. It could be 1 time or it could be 2. So if you look at graph A, it's hitting at 1, 2, 3, 4. It looks like at negative 5. There's 1 solution to this, and it appears to be at x equals negative 5. Number of real solutions here. Well, the graph is crossing here and here, and those aren't at like nice points, so I'm not even going to guess what those are, but that's 1 solution, 2 solutions. Here, graph C, it never ever crosses, so there are no real solutions there. If you want to put 0, you can do that too. And to find solutions on a quadratic function, if you have the graph, it's super duper easy. You literally just look again and see where is it crossing. So in this problem right here, I have 1 solution, 2 solutions. So it appears to be at x equals negative 1, and then 1, 2, 3. So at x equals 3. And every time that you find a solution to a quadratic function, whether you do it by graphing or square roots or factoring or quadratic formula, which we've done all of those except quadratic formula, but we're going to review all of them too at some point in the next couple of weeks. Every time you find a solution, you want to write it as x equals a number, because again, it's where it crosses the x-axis, so that's your solution. Okay, now in number 2, oops, sorry. So I have a solution right here at negative 1, then 2, 3, 4, 5, 6, 7, 8, and then right here at negative 8. So my solutions are x equals negative 8 and x equals negative 1. Now, the next thing, this is asking you to graph each of these in your graphing calculator. And I sent on that sheet I sent you, that was like the how-to sheet, it gave you a link to a what would look exactly like a TI-84 plus CE. And it's like a Chrome extension or a Chrome app or something. So you can download that. And it's pretty user-friendly because it looks exactly like what we've been using in class. The other one that you can do, just like an online one, if you don't want to download an extension, is through Desmos. So there's a link to both of those, on that document. I think it says like click here and the here is linked. But all right, anyway. So we're going to graph these functions and see if we can tell how many solutions and what are they. So remember how to graph. It's been a while. Hit y equals, I'm going to type in x squared minus 6x plus 9. And I hit graph. Make sure again that your window is on like a regular window. If it's not, I don't know why it wouldn't be on like a downloaded version of that, but maybe you have your own calculator or you're like sharing with a sibling right now and they've messed up theirs. So hit zoom 6 and that gives you your standard window. So this is going through, and if you can see, oh, that really doesn't work, so I need to move it over if I'm gonna zoom in. Again, this is like a little bit strange right now. So you can really see that is at 1, 2, 3. I just drew on my calculator, don't tell anybody. So let me back this thing back out here. All right, so you have one real solution. Again, I should put real in there and I don't. And then what are the solutions? It looks like it's at x equals 3. Then if you do the next one, so go back to y equals and clear this out, you do x squared plus 4. And you hit graph, and you have a little graph here that doesn't ever hit the x-axis. In fact, it starts at 4. And if you remember anything from transformations, it's because of that plus 4 that just moved it up 4 from its normal origin point. So that doesn't cross the x-axis at all. So that is no solutions. And then what are they? Obviously, there aren't any. All right, and then the last one here is y equals x squared. I'm just going to clear that, sorry. X squared minus 3x minus 10. And hit graph. And it doesn't matter necessarily that I can't see where, like the bottom of this, the vertex of it, the turning point, because again, I really just need to see where it crosses the x-axis. So this is at -2, and then 1, 2, 3, 4, 5. So it says 2 solutions. Sorry, I didn't mean to make it that small. 2 solutions at x equals -2 and x equals +5. All right, so those are our notes for today. And your like optional homework assignment today is this 9-2 practice A. And it's really just numbers 1 through 6 because, I mean, if you're feeling good about yourself, you can try 7, 8, and 9 if you remember how to find the axis of symmetry and the vertex, but that's something we're going to do tomorrow. So you don't have to worry about that, or in the next lecture I do. I don't know if it'll be tomorrow for you or if you're just knocking all these out at once. Excuse me. All right, so all you do for this, so like number 1, you just, again, look and see where the zeros are. So this is hitting the x-axis at x equals 0 and x equals -4. You're at x equals -4 and x equals 0. And in terms of these optional assignments, you don't need to turn any of these in. So even if you just want to like go through and do them, or even just like look at the assignment and say, okay, yeah, I get it, I understand how to do that, then that's fine as well. So like your Delta Math assignment, again, is the only one that you have to turn in at the end of the week, and it'll just really like combine everything that we do in the week. So that's why I put the optional ones on there so that you can kind of practice as we go through rather than just see it on Delta Math and be like, I watched that 4 days ago. What does that even mean? So anyway, as a reminder, I have my Zoom office hours from, let's see, Mondays from 10 to 11 a.m., Tuesdays 10 to noon, and then Thursdays also 10 to noon. So on Remind, each of those mornings I'll send out the meeting ID and password. And if you have questions on any of the assignments or on Delta Math or what have you, you can just join in that meeting. And then as soon as I answer your question, you can just leave the meeting if you want to do that. It'll be a little bit interesting because it's sort of hard to, like, I don't see the same Delta Math problems you do, so you'll have to make sure that when you're on Delta Math, like if you have a very specific question on that, if you don't mind just screenshotting that and then shoot an email to me so that I can know exactly what you're looking at. Okay? All right, you guys, have a good day. And again, let's see. Oh, I already closed it out, but I'll start every lecture as I start 5th hour, which is with, oh, it's my dog. So there you go. My dog will bark at you or there'll be a round of applause. All right, see ya.